So I start the recording now, and then I move on to my introduction of Alf Hornborg. Um, the first speaker is Alf Hornborg. Alf is an anthropologist and professor emeritus of human ecology at Lund University in Sweden. Most of his research has dealt with human environmental relations in different societies and cultures through history, the intersections of environmental history, world systems analysis, political ecology, and ecological economics. His books include The Power of the Machine, Global Ecology and Unequal Exchange, Nature, Society, and Justice in the Anthropocene, and The Magic of Technology. And with no further ado, the stage is yours. Alf, I don't know if you have slides that you want to share or okay.
Yes. Uh,
Yeah, the floor
have
is
you
yours.
have you enabled sharing? Yeah, that's fine.
I
Well,
hope so.
thank you, Cornelius, and thank you, Miriam, for the invitation. I'm really interested in the work your group is doing. I'm going to try to give a short introduction to my thinking about technology in relation to the topic of ecologically unequal exchange. And I guess what I want to say is that we have fundamentally misunderstood the very nature of technology for centuries and think of technology as a rather localized index of progress rather than as a global process of exploitation and resource extraction, which is my perspective on technology. And I realize this may sound very pessimistic for many of you, um, but I think it's necessary in the current moment of history to really rethink technological progress, knowing the ecological consequences and knowing the global inequalities that are connected to it. So I'll just start to try to share my slides here. Let's see, this should do it. Now, are you able to see this?
Not yet. I think you can choose the screen that you want to share. If at least this was and normally if you click on the share button, then you can kind of select the PowerPoint
Yes,
um,
of course.
window.
That's quite true. I usually I messed it up again here. Okay, excuse me just a minute. Here we go. This is it. Yeah.
Ah,
How
yeah.
about
Now it
this?
works.
Okay, yes, yeah. This
Perfect.
is so typical of my way of dealing with technology. I just get confused as soon as I start. Okay, so here we are. You can see this. Okay. Um, so what I want to argue, I want to give a big picture in quotation marks and begin with this image of the world system. And world system analysis has always been a central part of my argument. And we really need to zoom out and take a step back to look at what technology is from a global perspective. We think of it as development based on the progress of human ingenuity, but we can also look at it in terms of global distribution. And as you can see from these images, the first one is a map of GDP density produced by economists. It basically shows where most of the money in the world is being made, GDP per square kilometer. The bottom image is a satellite image of nighttime lights showing the technological infrastructure of the world viewed from outer space. And as you can see, the two maps are basically identical. So I would argue that the distribution of the physical technological infrastructure in global society is very much aligned with the distribution of money. That's my first point. Um, the perspective that I've been developing over a number of years on technology very much derives from the insight of Nicolas Georgescu Roegen, the Romanian economist, who in 1971 published a book called The entropy law and the economic process. And for me, that was a real eye-opener. I cannot claim to understand his algebra throughout, but I do understand his basic point. That is that any economic process will involve an increase in entropy, that is physical disorder. So what I basically did in terms of theoretical integration was to bring this insight from Jessica Rogan, who, by the way, is seen as the father of ecological economics and also of the degrowth movement, to bring that insight in connection with world system analysis, which was a perspective I was trained in anthropology through the work of André Gunder Frank and Immanuel Wallerstein and so on. If you bring these two perspectives together, ecological economics and world system analysis, you come up with something like this image, that the development of technological infrastructure in certain parts of the world, what I call technomass, relies on physically unequal exchange. Now, this implies a redefinition of unequal exchange in comparison to the kind of concepts developed by Samir Amin and Argiri Emanuel. I'm talking about physically unequal exchange in the rather simple sense that a technomass will require a higher input of high order matter energy than it discharges. It sucks, to speak with Erwin Schrödinger, it sucks high order matter energy from its environment and discharges low order matter energy or entropy. And what regulates the proportion between the inputs and the outputs of the technomass are market prices. So we could compare this to what an organism does, or the biosphere as a whole, where the input of high order solar energy is actually converted by the biomass into uh, low order energy in the form of heat, with which is dissipated from planet Earth. And this is a quite sort of natural process. But in terms of what happens in global society, of course, it's not a natural process. It's organized by social relations and through categories such as market prices. So this basic perspective, of course, with entropy and negative entropy or exergy is very difficult to develop because it's very abstract and very difficult to measure or quantify. So instead, I've been developing the concept of ecologically unequal exchange, which can be illustrated, I think, by this diagram that was compiled, these diagrams that were compiled by my colleague Christian Dorninger regarding world trade in the year 2007. The reason why we chose 2007, this is from an article that is about 8 years old, was that 2007 was a year in which we were able to assemble data on all these four categories of resources imported and exported from all these three core areas of the world system, the European Union, Japan, and the United States. And what these columns show is that for all of these three core areas and all of these four types of resources, we find a very similar pattern. The gray columns show the imports per capita, measured not in money, but in tons, gigajoule, hectares, and person year equivalents. These are biophysical metrics that provide a completely different picture of world trade than the metrics used by economists, which basically refer to monetary prices. But the gray columns show the imports, the black columns show the exports, and the white columns show the difference between the imports and the exports, that is the net imports. And what you can see in these diagrams is that there's always a net import to all of these core areas. Now, the picture would be very different if we analyzed areas in the peripheries of the world system, nations such as Colombia or Brazil or so on, then we would have net exports. But this is a pattern that's very typical for the core areas, a term borrowed from Immanuel Wallerstein. Well, there's a lot I could say about these diagrams, but I won't do that. I mean, you can see, for example, that the category of embodied land in relation to the trade in and out of Japan is very telling. I mean, there's very little export of embodied land, and the import per capita of embodied land is basically all net import, which is like 1 hectare per capita to Japan. And there are several other examples we could discuss in these diagrams. But the problem I want to discuss also is the fact that this physical material aspect of global economy has escaped us. And I think this has very much to do with the way we in modern thought tend to distinguish technology from economy. And in this respect, I very much agree with the perspective of Bruno Latour, which he expressed already in 1993 in We Have Never Been Modern, where he argued that the distinction between nature and society in the modern worldview is arbitrary, ideological, and highly misleading. And I would argue that this in fact has produced our current understanding of what technology is. Given this dualistic understanding of nature versus society, we have tended to conceptually distinguish between technology and economy. Technology as belonging to nature or referring to nature and being studied by engineers, the market and the economy as being social, relational, and studied by economists. Uh, my my alternative to this view of the world is that technology is constantly being generated by the economy, and that technology and economy cannot be separated because technology is basically a product of economic relations. Technologies are founded on social exchange relations, that is, trade. And the reliance of modern technologies on ecologically unequal exchange is invisible from mainstream economics. Technology is treated as an extra social phenomenon. It is often referred to as a parameter that does not require social deconstruction or social understanding. It just is there. It's a question of how we have developed human ingenuity rather than how social exploitation has expanded in terms of space and time. The only possible way in which mainstream economists might consider trade unequal is when market mechanisms are manipulated, as in monopoly. There is a traditional usage of the concept of unequal exchange, even in neoclassical economics, but only applied to instances where market equilibrium is somehow distorted through monopoly or monopsony. But I noticed that in a recent textbook, like the fifth edition of Krugman and Wells textbook, Economics, which has a 27-page, 4-column index, there is no mention of the word unequal exchange. So unequal exchange fundamentally does not exist in the cosmology of modern economics, and I think this is quite significant. I want to discuss also a book I read recently by Jean-Baptiste Fresseau called More and More and More. Some of you may be acquainted with it. I find it extremely enlightening. And from a historical perspective, he basically makes an argument which is very which harmonizes very well with my own argument on ecologically unequal exchange. He says in this book that historically there has never been an energy transition. New sources of energy have merely been added to previous sources, and each new form of energy has required specific kinds of materials that are contingent on earlier forms of energy. And he provides several very enlightening examples, like the wooden mine props that were used in coal mines during the 19th century. He says that by the year 1900, there was about 6 or 7 times more wood used for energy production than 100 years earlier because of all the mine props used for mining coal. So here, wood was absolutely essential for coal extraction. And in a similar way, coal has been absolutely essential for the extraction and use of oil and gasoline because the cars that use gasoline have been produced with the aid of coal. As you know, coal is essential for the production of steel and cars are usually made out of steel. And of course, this raises question of what is this notion of a green energy transition? Can we really, given all this historical data, can we really expect a transition towards a green technology that is using renewable energy sources? When we know that those energy technologies are fundamentally based on fossil energy, the production of technological infrastructure for nuclear power, hydroelectric power, solar power, wind power. It's very difficult, as Václav Smil and others have argued, to imagine a society, a global society, with current levels of consumption of energy and materials based on renewable energy. Um, so we can show that between 1980 and 2010, global coal use doubled and the consumption of oil increased by 60%. This was during three decades, I'm sorry, in which we were all very well aware of the problems with fossil energy and the necessity of transitioning towards renewable energy. So I think we need to ask a basic cosmological question or philosophical question. What are we trying to do in this uh, constant struggle to create new technological solutions? What is our ultimate aim if we're actually destroying the biosphere in the process? I mean, what are we aiming for? And it struck me that if you go back to about 400 BC to Aristotle, you can find in his book Politics speculations about what the world would be like if uh, you didn't need slaves, if you had mechanical slaves that basically um, did the work on their own. You would rid yourself of much of the moral and political problems of having to base your society on slaves. So, from that perspective, of course, we could think of modern robots as exactly the kind of mechanical slaves that Aristotle was dreaming about 2,400 years ago. And we could even argue that machines, ever since the Industrial Revolution, have been created in order to replace human and animal labor. They are, as I sometimes say, counterfeit organisms that are supposed to replace uh, organisms like slaves and draft animals, but that actually tend to displace slavery rather than replace slavery. I'll get to this in a moment. And then we argued we should use solar power instead of fossil energy. Uh, but what is solar power other than an attempt to create artificial photosynthesis, to use solar energy directly converted into usable energy for humans? We could even talk about the contested topic of artificial intelligence. Do we need it? Or might it even be preferable to have human intelligence? Okay, so this is a question of the philosophy of technology and our whole perspective on technology. As I said, machines do not replace slavery as much as they displace it. This can be shown by referring to the way in which the Industrial Revolution in Britain was contingent on slave plantations in America. And I would argue that very similar patterns can be unearthed in the modern world. We have extreme examples like the modern green tech using cobalt extracted in West Africa by child miners paid the equivalent of $1 per day. I recently read that Jeff Bezos, already 7 years ago, could earn like $275 million per day. That is a measure of the obscenity of the world system we're living in. And interestingly, it is very much mediated by the role of technology in the world system. The green technology based on cobalt and other rare earth minerals. Okay, this is my final slide. I just want to say that I do believe we need a green transformation, obviously, but it must begin not with new kinds of technology, but with new kinds of money. The rationality of a technology is generally determined by the market, by the prices, the rates at which resources, including embodied labor, can be traded between the global south and the global north. And merely the use of conventional general purpose money intensifies global exploitation of the lowest wage labor and the least protected environments. This is logically intrinsic, inherent in the logic of money as it's currently designed. A green transition would require a fundamentally redesigned world economy in which complementary currencies with spatially restricted reach, distributed as basic income, would generate a localization of social metabolism rather than unequal and unsustainable global transfers of resources. And I think I'm sometimes asked what kinds of technology I think we could continue to develop in a sustainable world. And I would answer that uh, commodity chains are so complex that it's simply impossible to figure this out beforehand. But I think it's more realistic to try to transform our economy and see what kinds of technologies we might have 100 years from now, if we survive the Anthropocene, if the biosphere is actually still intact by then. Okay, I'll stop there and I'll stop sharing.
Thank you very much, Alf. That was fascinating, very interesting. We will save questions, etc., for the discussion in the end, and we'll continue now with the second presentation, which will be made by Miriam Boyer and Carlos López. Miriam is the project leader of the Biomaterialities research project here at Humboldt University. She is a sociologist with an interest in political economy, political ecology, and the history of science and technology. Her work deals with agricultural biodiversity, biotechnologies, and conceptual issues in understanding the nature-society relations, including technology and work. Carlos is a professor at the Center for Demographic, Urban, and Environmental Studies at El Colegio de México in Mexico City. He is an ecological economist working with input-output models to understand the economic dimension of water use. He also works with critical theories to analyze the relationship between nature and society and teaches on this subject. So the floor is yours.
Yeah, thank you, Cornelius. I'll try to share my screen. You can see it, right?
Yes.
Okay, very good. Well, yeah, it's nice to follow Alf's talk, because even though I guess on the surface our presentations will be quite different, I think they both underlie a concept of technology that is actually quite similar. And I know, Alf, that you have used actually input-output to kind of, yeah, show some ground empirically the theory of ecologically unequal exchange. So it's nice to have this exchange with you, and then the comments by Walther. So the title of our talk is called The Technological Structure of the Economy, Materiality, and Emergence Using Input-Output Economics. And I know that basically we have 5 terms already in the title that probably need explanation. And we will try to do that in the course of the talk. So the first explanation is already why highlight the materiality, the notion of materiality in relation to technology. So materiality in the context of technology has been discussed, but mostly in its biophysical sense. That is, regarding artifacts or material and energy use, and it has been highlighted as an important issue because of its effects. As Langdon Winner classically argued back in the 1980s, technological artifacts are not just innocent. You know, the way a bridge is shaped or a harvesting machine has political effects. And the same goes for what we just heard regarding ecologically unequal exchange with social relations of inequality, impoverishment, and so on. And even from a perspective of life cycle assessments and so on, we're interested in the biophysical materiality due to the environmental impact. And here in the type of materiality that we want to suggest as a concept using from the lens of input-output, we want to capture those biophysical aspects, but input-output is also able to capture, bring them together with the materiality of social relations. Also, it is an approach that can be amenable to quantitative empirical research, including modeling, estimates, or planning, something that connects with the first session that we had this morning on planning. And we want to suggest that also input-output approaches capture interactions. I mean, they do capture interactions at multiple scales, and we want to suggest that these result in effects that could be understood as emergent processes. And now, when we get to that part of the presentation, I'll say what we mean by that. So input-output economics was an approach in economics developed by a Russian-born economist, Vasily Leontief. He was awarded the Nobel Prize in economics for this work on input-output in the 1970s. He was an economist in the classical tradition who emphasized the interdependence of processes in the economy. And what interdependence meant in his input-output scheme is specifically the interdependence of economic sectors regarding one another. So what you see on the left-hand side, don't worry about focusing on any of the details, but you see economic sectors listed across the top and the column running across the bottom. And so the basic premise of this is that each sector in the economy requires inputs from the other sectors and at the same time provides outputs for the other sectors. So you can think of, and that basically having all the sectors here captured by this table can capture all of the interactions in an economy. And this can be measured both in monetary units, but also in physical units. Nowadays, detailed tables, input-output tables exist for nearly every country in the world, and they can be extended to include the information beyond sectors. So you can include things such as households, and as you will see later on in our presentation, you can include also certain types of social relations and even international trade, which is something that is depicted here on the table on the right-hand side. where you can see an input-output table in a very schematic way that is able to represent the kinds of issues regarding trade and the flow of matter energy that were just raised by Alf's talk. And so the question is, what does all of this have to do with conceptualizing technology? Leontief pointed out that the interrelationships shown by the input-output table could be described as the technological structure of the economy. And Leontief was not out to really theorize technology the way we're doing in our papers and in this talk, but I want to point out here that talking about these interrelationships in an input-output table as a technological structure points to a really very, very different concept of technology than one that would be captured by artifacts, or even an artifact such as a harvesting machine, or a technological process such as, I don't know, biomass generation, for example. Because what he's pointing out here is that these interrelations imply a technological relationship. And this relationship consists, on the one hand, of material inputs and outputs flowing across sectors of the economy. And also, it implies the social relations that uphold them. Now, Leontief also referred to these interrelationships in the economy as a cooking recipe. So, for example, if you took, I don't know, the case of the Mexican economy, and a recipe for it that would express its technological structure could mean a lot of different interrelationships that we've tried to put here in a visual sense, such as small farmers, small-scale farmers working with a lot of manual labor, but also perhaps industrial farmers, a petroleum industry, financial and medical services, manufacturing. All of them engage in particular relationships that that imply the certain flow of materials in certain proportions, and that implicitly also imply certain social relations that uphold them. In input-output models, this interdependence is expressed and investigated mathematically. And so you have mathematical expressions or quantitative expressions of specific patterns of social reproduction. That is, how much I use of a certain resource and give to others in terms of inputs and outputs. You can also see, or you can also express mathematically the weight of different groups in this relationship, or, for example, how the technological structure is modified by changes in production, consumption, and trade. And now I'm going to give hand the presentation over to Carlos, who will show what we have done using input-output in terms of a numerical example, where we're trying to show the relationships, how input-output and the fact of being able to capture the interrelations in an economy at this scale is able to show how technological processes can relate to the larger interrelations in an economy, and what types of new social and technological relations we can see as a result. So Carlos, if you want to continue.
Yeah, thank you very much. I would like to talk and present the next 2 or 3 slides, trying to explain a little bit about this research that we have been doing on the concept of technology using input-output. So the main idea is that input-output economics is a way of understanding technology, describing technological processes by the inputs and the outputs, just as Miriam was describing now. But the idea is that we see in the literature, in the recent literature, I don't know, the last 2 decades or so, a certain movement to try to include more dimensions, more variables into the descriptions of technology. And 2 realms are quite important, which is the environmental or the ecological dimension of technology, and then the social dimension of technology. So there are in the development of input-output, there has been a very fruitful relationship with engineering and the field of industrial ecology, in particular, developing life cycle analysis. So life cycle analysis usually work at the level of a process or a particular industrial facility and so on. And then the relationship with input-output enables a way to study the interactions of that particular process with the rest of the economic system. And those methodologies are called hybrid LCA. And we were trying, in this numerical example, we are trying to add to that literature, to that particular field of research by expanding the capabilities of input-output economics to include more social variables. So what you see here in this diagram, you see a foreground process, and we are using an American example that has been created some 20 years ago by Sang-Won Soo when he was developing particularly the relationship of process-based LCA with input-output tables. So he's talking about a particular process, a toaster in its life cycle, and you can try to describe the process to a particular extent. And that process, which it is called the foreground process, emits some CO2 and so on. And then the methodologies started to develop to include the interactions of that process with the rest of the economic system, which is represented by an input-output table. So you have the production network that Miriam was describing before. And that's hybrid LCA. And what we are doing here with this numerical example is adding to this approach by including more elements of social reproduction, if you will, which is the provision of labor by households and the needs of these households. So households provide labor, but to do so, they need to consume goods and services, and then the economic system need to produce these goods and services, and then you need to account for all these feedback loops. And this is what we have done with a numerical example. So we call it hybrid social LCA, just to follow the naming tradition of this research field. And we are describing social LCA at the process level, in which you have a description of the labor use and the household consumption and so on that is directly related to any particular technological process that you might be interested in. And then we have a relationship with the rest of the economy, which is now represented by a social accounting matrix that includes an input-output table, but also adds to the input-output table the provision of labor and the consumption of households. So you want to include all these interactions and all these interdependencies into the analysis to then ask questions about environmental impacts, which in this example is represented by emissions of CO2, but also you can have particular questions about the type of labor that gets used, the amount of labor that certain technologies might be using, and so on. So if we go to the next slide, please. The next slide shows the results of the numerical example using this example by Sang-Won Soo in the literature. So you have here a comparison of CO2 emissions coming from different models. So you have in the vertical axis CO2 emissions, and then in the horizontal axis you have different processes, the production of steel, electricity, the toaster itself, and so on. And then you have the sectors of the economy in the background: agriculture, mining, manufacture, and so on. And what you see in the graphs are the graphs represent the outcome of different models. So you see the process-based LCA, which is the analysis only based on the particular process, which are the white bars that you see here, only account for 18 kilograms of CO2 emissions, and most of them are produced in electricity, and some of them are produced in steel, and so on. And as you go forward with the different models are including more feedback loops into the analysis. And then, so you have social LCA, and then you have hybrid LCA, and you're including more feedback loops with hybrid LCA. Now you can account for the emissions happening in the economy in the background. And the last model with the black bars is the hybrid social LCA, including the social accounting feedbacks into the picture. So you see there the differences in emissions that the modeling take into account. The hybrid LCA, the hybrid social LCA account for 60 kilograms of CO2 as opposed to 18 only in the process-based LCA or 30 in the hybrid LCA. So the main idea here is that the modeling framework expands the notion of technology and make endogenous several processes that were treated as exogenous with previous models. So if we go to the next slide, please, just to give a brief summary of the results. The materiality of a technological process, which in this case is a toaster, but this works for any process that you might be interested in, provided that the process is smaller than an input-output sector, because if it is at the size of the input-output sector or bigger than that, you can just directly go to the input-output table. So the materiality of a technological process is described by the input-output relationship with the wider economy, including all the feedback loops between production, labor, and consumption. As I said, previous approaches would only take into account the production of the input-output relations at the production labor level, and we want to include also labor and consumption. It's also described by the environmental impact, which in this case is CO2 emissions, but this could change. This could represent, for instance, land use or water use or different minerals, and you can produce different computations for different natural resources or emissions of pollutants, and you can even link that with the input-output table as big as you want if you want to work with a global one, and then you can produce the type of material footprints that Professor Hornborg was talking about in the first presentation. And the materiality of technology is also described by some social aspects. So in this example is labor use, income generation, and distribution, but this also could be expanded to include more social dimensions like gender, perhaps if you have informal labor, or what is the situation with unionization and so on. You can expand that. Of course, you are going to need more databases to include all that information into the model, but at least in principle is to have. So the basic idea is that technological processes are described assuming non-separability of these processes between the environmental impacts, but also the social dimensions. You cannot separate those things, and you need to understand technology including these things, because otherwise then it's like, as Professor Hornborg was describing, you sort of naturalize technological relationships, and then you lose the social dimensions to it. So I'll leave it here, and I go back to Miriam, please.
Yeah, thank you, Carlos. So yeah, you just mentioned this issue of the non-separability, which goes to the heart of this concept of technology that can be seen with input-output, about not separating the environmental dimension from the social dimension and from the actual maybe technical process that's going on. And just to finish the presentation, I want to go back to these larger conceptual issues also by saying that what Carlos just showed in the numerical example, I mean, from a maybe an engineering perspective, of course, it shows a more accurate estimate. This CO2 example was to show that the more complexity you show in the interrelations with the input output, taking into account the social relations and so on, the higher the CO2 estimate. But what we want to suggest conceptually, and it would be interesting to hear from you whether you think that this is the right way to think about it, is that this higher CO2 estimates are also an expression of emergent properties that are being shown, that are happening at the economy level, and that are able to be captured through all the interactions that are going on in the economy that you can see through input output. So Emergence is, here we have a definition of emergence offered by critical realist theorist Dave Eldervas, who suggests that emergence happens when you have qualitatively different effects that would not be visible if you didn't take an entity, the parts of an entity into account. So a classical example of this would be water as an emergent process emerging from the two. So water is made up of two different molecules, hydrogen and oxygen, which have very different properties, but when they come together to form a water molecule, we have qualitatively different properties. So that is like a textbook or an easy example to show what emergence is. And we're trying to suggest that the effects that we see here with CO2, and it could be CO2, but it could be possible to express them if we had chosen a different research question to talk about something else, such as labor or trade or inequalities or whatever we choose to model with this, that these effects at the economy-wide scale are not just aggregate effects, but that they are there. They're emergent effects in the sense that that can be accounted for because of the biophysical and the social interrelations that can be accounted for in this type of model. And to say that this is a way of expressing the materiality of technology, combining the biophysical and the social relations in a way that is also quantifiable and multiscalar. And so to conclude, what we tried to show in the two papers that we combined here, I wanted to say this in the beginning, this research that we just presented is the combination of two papers, one that is showing the numerical example that Carlos described, and one that is trying to use the concepts offered in a more conceptual way. And Matis, who is here, who is a student in the biomaterialities research group, is actually writing that paper with us. That input-output in economics can provide a useful framework for understanding the materiality of technology. So on the one hand, a view of the economy with this idea of a technological structure that is based on interdependencies that imply both biophysical and social relations. Multiscale interdependencies of the microprocess of, say, a technological process such as this toaster use that Carlos referred to, meso-level processes such as the economic sectors and the economy-wide interactions that can be understood as technological relationships, and these relationships are made up of the material flows and inputs and outputs, but also the social relations that uphold them, and that we can understand these not only as more accurate estimates of environmental impacts due to feedback loops at the economy-wide scale, but also as emergent processes. And finally, we want to suggest that this type of analysis is actually a very nice way of collaborating between the quantitative and qualitative social sciences to understand technologies in their social and ecological complexities. So while qualitative analysis tend to highlight, the interrelations or the use of these very abstract terms, here we have a model that is complex enough to take into account both of these biophysical aspects and also the social aspects, and to combine them in a way where quantitative and qualitative work could be very fruitful to be done together. So yeah, with that, we'll end.
Yes, thank you. I was using the clapping the hand symbol. Thank you very much for this very, very interesting presentation. I now hand over to Walther, who's the commentator. And let me formally introduce him. We now turn to comments to be made by Walther Zeug. Walther has a doctorate in engineering. He is a researcher and leader of the research group Integrated Sustainability Assessment of Societal Systems, or ESAS in short, at the Helmholtz Center for Environmental Research in Leipzig. His long-term research interests include inter- and transdisciplinary sustainability research, sustainability analysis and assessments, political economy and ecology, as well as democratic economic planning. The floor is yours, Walter.
Thanks. So you should already see the presentation, right?
Yes,
Okay.
yes.
Yeah. Okay, thanks. Yeah, so we already have discussed, especially with Carlos and Miriam before, that I actually mostly agree to to all the things which were actually said. I feel more in the role of maybe adding a little bit to that by a small synergy, also drawing again to the first session of this talk. Where I think in the problems which actually are posed to us, these are actually problems of democratic economic planning, and which can help us to shape sustainable societal metabolisms. And I would like to start with one concept, which the presentation is, yeah, okay, I have to do it here. So it's, sorry. So what you can see here is the quantitative, qualitative development of the production of commodities measured in GDP, as well as ecological impacts and resource use, as well as the degree of fulfillment of societal needs here measured in the HDI indicator. And what you see is an exponential growth in the production of exchange value specifically. And however, so also an exponential growth in ecological impacts and resource use, however, only a linear increase in the degree of fulfillment of societal needs. So what you here basically see is the hierarchy between exchange value and use value in capitalism. And I think a society ecological transformation should go for something like this. So that means the exponential growth in the degree of fulfillment of society needs. So this is also from a global perspective important. However, the necessity to decrease the production of commodities or better goods then in order to get below the planetary boundaries. So this would allow us to achieve social sustainability, which is precisely to have a good life for all. And the economic sustainability is that we have economic structures and technologies which are so effective, efficient, and just that we actually enable us to achieve all this within ecological sustainability, which means staying within planetary boundaries. So the question is more or less, how can we achieve actually a good life for all while staying within planetary boundaries? So I think it's a double decoupling problem. The first dimension of decoupling is the decoupling of the fulfillment of societal needs from an ever increasing production, which means sufficiency and effectiveness of production. And the second decoupling dimension is to decouple the then sufficient material production from increasing ecological, societal, and economic impact, which means efficiency and also the need for technological advancements. If you are talking about sustainability assessment in LCA, so the second decoupling dimension is what is typically discussed in LCA. This is the question, is product A better than product B? However, the more decisive question is actually, and this is the question of absolute sustainability assessment, as we call it today, how much of the product A can we actually produce within ecological and societal boundaries? And this problem is not only a problem of absolute sustainability assessment, but if you take it really seriously, it's a problem of democratic economic planning. So the challenge is basically to, and I have to, make it small, so like that, to identify viable pathways to determine which and how much resources can be used for which economic, technological, and societal practices to actually sustainably satisfy societal needs. Okay, when we are talking of boundaries, typically we are talking of planetary and regional ecological or societal boundaries, and then we can downscale them or allocate them to a per capita things. So what you see here is insights from Earth System Sciences. So you can basically roughly say that about 5 tons of raw material consumption per person per year are considered as sustainable, as well as 1 ton of CO2 emissions And you can also consider 2,350 hours of working time per person per year as some sort of realistic, because this is at the moment the paid and unpaid work, so including care work, including unpaid care work, which is actually at the moment done in Germany. Of course, this can be less or should be less. This is something to discuss, but you can break things down to these, let's say, main three numbers. So the question is then how to upscale or allocate this to different production sectors and products. For this, we came lately up with a model of cybernetic democratic economic planning. This makes use of what Carlos already said with the hybrid LCA, and I will show you like a very basic introduction to that. So with the HILSA method, the HILSA method is a life cycle sustainability assessment method, which I developed in the last years. And basically LCA, as Carlos already explained, is an input-output method, however, on the process level. So we let's say, consider economies at networks of processes which have inputs and outputs. Cybernetics, on the other hand, mean that we control complex systems such as global economies by a democratic parametric control of the framework and not of all the details. So it's not a top-down planning, but it should enable local individuals and organizations to act so autonomously that they actually achieve something like a multi-level iterative coordination. So this is very much in hand what also Drew Pendergrast presented at the very beginning of today. So what we are in need of is actually a differentiated, multidimensional, and complexity-reducing system of parameters for accounting and budgeting. And for this, we propose tokens. And these tokens are non-circulating units of accounts that reflect information about costs, scarcity, utility of products and services. However, not to mess up with money. So how does it work? So if you consider what I just presented, raw material consumption, greenhouse gas emissions, and working time with these specific limits as sustainable, you have to split them up into 5 main areas of consumption globally: universal basic incomes, reserves, universal basic services, non-institutionalized care, and productive consumption. All of these activities, let's say, or all these sectors of societal consumption are part of this consumption and reproduction system and need products and services from the production system itself. We can measure precisely which working time, greenhouse gas emissions, and raw material consumptions are, let's say, the effect or needed for these production systems. And from that, we can calculate economy-wide impacts. And when is the system or this economy sustainable? Precisely then, when the economy-wide measured impacts are within the boundaries we defined before. If this is not the case, then you have to adapt. And that's why cybernetics, because you see the first feedback loop in the system. What you can also calculate here is product prices as a share of the actual impacts of products and the per person sustainable budget. So these prices are, let's say, raw material or material, climate, and social prices of products. And they then can incentivize the consumption system. To actually do such calculations, we need something which we call an environmental and social extended multi-regional input-output analysis, which goes very much hand in hand to what already Carlos proposed. So this hybrid LCSA is basically an integration of bottom-up and top-down input-output from macroeconomic input-output and LCA. So first, you consider the resource inputs for every production sector which are sustainably available in fossil, biogenic, and socioeconomic resources. You then see, okay, which production sectors are actually consuming what and in which interaction they stand to each other. And at the end, you check, okay, which consumption outputs do they actually produce for these 5 consumption sectors we defined. The LCAs then describe the technological pathway resources take through the economic system to the consumption outputs. And this is like the environmentally social extension here. We are defining these lead indicators of raw material consumption, greenhouse gas emissions, and working time, which we can here model for the entire economy. On the most important level of decentral parametric allocation, you can imagine the system like the following. So considering yourself as a kindergarten or so that means an institution of universal basic services, you have the need for bread consumption. And this bread consumption has to be provided by a bakery, and the bakery again needs wheat from a farm and machines from a factory, like an oven. So we know precisely from the LCA calculations which resource, greenhouse gas emissions or climate, and working social price in terms of working hours is embodied in the bread. These tokens then get passed through the supply chains to signal the relevance and to actually account the impacts and the efforts we have to make as a society for all these different production steps. So this is the simple reproduction sphere. And what you see here is more or less, if you refer to Marx again, it's a good token, good economy. Yeah? And the nicely effects here are that if company produce very efficiently, then the more tokens get passed to this company or to this enterprise, and they are the signal of societal relevance of production. However, it's a solidary competition. That means if you have two bakeries, then it doesn't mean that and one bakery A produces more efficient or the better bread, doesn't mean that bakery B goes bankrupt, but they can have an exchange in coordination. The good thing is also if framework conditions like CO2 emissions, available CO2 emissions change, you can also have an automatic adaptation of this system, because then the tokens will flow to the bakery, which produces better accordingly to the changing surrounding conditions, for example, by having a better oven which is less CO2 intense. There's also a mechanism for investments, which I don't go into detail here now, but you can have a look at the presentation at ResearchGate later if you're interested in that. So at the easiest level, you can imagine the everyday pricing information in cybernetic democratic economic planning as a three-dimensional price of raw material consumption, greenhouse gas emissions, and working time. So with that, I want to end, let's say, my concluding adding remarks on how synergies between non-monetary units of account and methods of hybrid sustainability assessment of LCA and input-output could look like in a, let's say, transformative approach on economics.
Yes, thank you very much, Walther. Very interesting. You're done, right? Yes, I understand it correctly.
Yes.
Yes. Yeah, I also found it very interesting because our session, the last session, ended a little bit with a question of like alternatives to venture capital financed innovation. And I think your talk and also the talks by the others provided many very interesting ideas to alternative ways. But yeah, are there any reactions from you, Alf, or Miriam, or Carlos to Walther, or shall we open the floor to questions from? Okay, yeah, I see Alf has a comment, a question.
Yeah, I mean, this was very interesting. It did raise several questions for me. I remember you're using the word use value, for example, which I find quite problematic. Because it's a concept that integrates economic thinking, the idea of value, with some kind of physical material use. And I think it confuses us more than it actually clarifies. But that's a small part of my question. I guess I'm interested in knowing what you mean by social sustainability for all. This is a phrase you used. I'm wondering whether that would include the global system. I mean, you talk about systems and cybernetics and so on, but when you talk about the factory and the machines that produce the bread, are you thinking about including all the global inputs into the technology? I mean, in a way, we're back at the Industrial Revolution. We have to realize that all these investments in technology have global implications, which the people in Britain did not see. And I'm wondering whether you have accounted for the global inputs of labor and other resources into the technology that you include in the category of factory.
Walter, you're still
You're
muted.
muted.
Sorry. Yeah, going back to the concept of use value. So basically, this is quite post-Marxist inspired analyses here, and also all the terms refer to that. So by use value, I mean the practical utility or usefulness of a commodity or a good. So basically, its ability to satisfy human needs or wants. I mean, of course, we could have an extensive discussion on if this is a proper term or not, but I think it's a good term to differentiate between use and exchange value, which is in capitalism, exchange value is, let's say, the dominant form of value and the leading form of value, which organizes how economies work. Regarding the second point, I was actually I'm actually a little bit prepared for the question of how to model global supply chain impacts. And because I was also very much talking about that with Carlos as well before, the good thing is in LCA you can do such, you can account such global implications of supply chains. And if I can, I would just show 3 slides. Here you can see the global CO2 footprint. So the global CO2 footprint of a basket of products of the current German consumption. Now, so this is a basket of products of one person and the consumption of goods within 1 year. I don't go into detail too much, but here you see the global CO2 footprint of this production system. Of course, a lot of the production is also taking place in Europe, but you see all the effects in especially China, Brazil, and Russia. If you are looking more closely to the resource use and minerals and metals, you see it even more. You see already how the global supply chains act here. You see Australia, South Africa, Chile, as one of the main, and as well Russia as one of the main producers of raw materials. And if you have a look, which I found specifically very interesting, on the global labor footprint, you will see that the German economy is very much dependent on externalization of labor time. Here specifically, you have a very high impact of labor time in India. The reason for that is that India is one of the biggest or the second biggest producer of hard coal. And the labor productivity of hard coal mining in India is very, very low because basically the people are economically, they get less than $1 in hard coal mining per day. And a lot of the, let's say, clean technologies we apply in Germany are actually based on a fossil-fired global supply chain system, which is mainly, let's say, fired by work done in India. So that's why you have these huge shifts of working time and social impacts to India because of the fossil fuel extraction in terms of hard coal mining there. So yes, it is actually possible to do such things in LCA. However, of course, we have to say these databases are not perfect. Yeah, so there are a lot of insecurities, but you can see these global shifts.
Can I just follow up on that?
Yes.
I'm wondering if you're factoring in prices. the price of Indian labor, the price of minerals from South America, and how do you account for the fact that the import of all these resources into Europe is very much dependent on getting the prices right?
Yeah, so this is not anymore the part of what I do. So here I have to refer to where the databases are being, where the databases come from. And this is a very, very complex discussion now, how these databases actually come together. But you can imagine it like this. Behind all these data are market studies, which in mostly a 5-year span are conducted and then go into these models here. Yeah? So what you have seen is more or less a snapshot of an economy 5 years ago. Yeah? And its distribution according to prices. Of course, this can change. For example, with the war against Ukraine, you would see a shift away from Russian gas more to American LNG. Yeah. So this would be the next snapshot in 5 years, with different and resource extraction according to that.
Hey, are there any other reactions in the audience? Miriam, Carlos, do you have any thoughts on either what Walter presented or Alf's reactions to it, or?
Yeah, I can. Yeah, I can share a couple of thoughts that I find very interesting on both Professor Hornborg's presentation and also what Walter shared. And I guess that what I think that it's a very fruitful field for discussion is this monetary slash token aspect of these things, because I guess that we can agree, for instance, in this idea of technology being contingent in these social relations and market transactions. The way in which an input-output table shows the interdependencies of technologies is through these market transactions, which are actually what is represented in the input-output table. So that is, and now Professor Hornborg also asking for the prices of things. That is an aspect of the thing, because input-output tables usually are represented actually in monetary values because of ease of getting the data and representing the data, although you could also translate those monetary input-output tables into physical tables. And there is a huge debate and literature of input-output of ways to deal with that. But I guess that the question here is how this money value thing, this money veil, how that influences the adoption or the diffusion of technologies. And for instance, in the context in which Walter was discussing in this discussion of planning, what is the role for this? Although it's not money, if I understood correctly, this idea of a token, although it serves one of the functions of money, which would be like to connect transactions and so on. I think that's very helpful. And one of the things that came to my mind while listening to that is in the input-output tradition, there were some models, and I have worked with those models at some point in the last, 10 years, that models that take into account these constraints. For instance, you can constrain your production by the availability of resources. Very much in the way in which you're talking about these budgets. Perhaps you have a budget for CO2 accumulation in the atmosphere, but you have a budget for extraction of water from sustainable resources or the use of land because you don't want to be leveling off forests and so on. So you have these restrictions, and you include these restrictions into the economic model, and then the economic model becomes an optimization problem, or it's treated as that, as an optimization problem. And an outcome of the optimization is what economists call shadow prices, which I think it's very similar to what you were talking about, Walter, because a shadow price will tell you the contribution of a particular good or service to the objective that you're trying to optimize for. So, for instance, if you're maximizing wealth or well-being, or you're minimizing cost of production, you can choose about over several objectives, and the shadow price will tell you the contribution of that particular thing, and that is like it's useful as a tool for planning. And I think that it's an interesting field for discussion about all these issues. No, and now I'm also interested in perhaps hearing a little bit more of Professor Hornborg's ideas of these currencies that are spatially differentiated, and then you will have, of course, several exchange rates now, and I think that is a very interesting field of discussion that perhaps we can devote some minutes to. So I don't know, Professor Hornborg, if you could expand a little bit more on that idea of currencies, and if you see like a correlation with this token idea that Walter was describing.
Can I respond to that? Yeah, thank you, Carlos. Yes, I was also fascinated by what Walter was saying about tokens, and I would, because I've actually used the word tokens for my complementary currencies in some of my publications. But of course, the big problem with all these grand ideas about redesigning money is the question of implementation. And that's why one of the questions I also would have wanted to put to Walter is, how do you imagine the conditions, the social and political conditions for actually implementing these grand schemes? I mean, it's wonderful to see that we can actually calculate how to become sustainable. But the big problem, of course, is that we have a political system and a social system that makes it completely impossible. We are completely ruled by money in the conventional form. There are no tokens, there are no complementary currencies, and I think if we try to implement them, we're going to run into a lot of problems, a lot of political resistance to the idea. So I guess that would be a question, if I can hand that over to Walter. How do you see the conditions for implementing all these fantastic ideas?
So first I maybe start with implementation. I could make this easy now and say, yeah, you have to abolish capitalism. And that's the end of the story, I mean, for sure, this is like cybernetic democratic economic planning is something which is explicitly an idea, an approach, a proposal for an economic organization beyond capitalism. So this will never work within capitalism. That's for sure. Yeah. So it is really, you could call it an utopian discussion, which I found nevertheless necessary. However, of course, this is not the end of the story. So for transformation, what you can do actually tomorrow is, and this is what we are aiming for in a way, the calculation of these prices, so the social price, the labor price, the resource price, and the climate price, these calculations is something you could do tomorrow. And this is something which you can print as a label on a product if you would like to tomorrow, because you do not need, let's say, the huge complex of all this planning economy or so to actually give products the information about their true price. I really explicitly say it like that, about their true price in terms of raw material consumption, climate, and labor. So, I mean, of course, this is now, this is a discussion with a lot of implications about such a transformation process. As you all know, by watching the news, we are far from anywhere going into that direction. That's completely clear to me. However, I think it's important to just show that from at least theoretical standpoint, we can not just only say we have to abolish capitalism, but we can say yeah, we have to do that, but there are good ideas on maybe how to structure things better beyond capitalism today. Also, another thing I wanted to say is about the money for these prices and the tokens. So we will elaborate on that in very much more detail in a paper, but these tokens are not something like money, mainly because they cannot be accumulated and they cannot be privatized, especially organizational tokens cannot be privatized, as well as they are not circulating. So these are, let's say, three attributes of money, especially in capitalism, which tokens do not share. You could more think of tokens as let's say, sort of objective measurements of, in this case, raw material consumption, greenhouse gas emissions, and labor implications.
Can I just get back to a question I raised before, or are we out of time?
No, I think like it is scheduled the discussion until 1930, but I think if we don't,
yeah.
no, I think there is still time, but then we should kind of slowly come to an end in order, yeah, not to overstretch.
Yeah.
I think. But
And I don't want to take all up. I don't want to take up all the rooms here with this model. So if there are any other questions, go for it.
Okay.
But as you like.
No.
Let's see if there are any other questions they want to raise. Anybody?
I'm very happy to follow the discussion. I find it highly interesting. So yeah.
Okay, I just want to put this question again about use value. I'm sorry for this hang up, but you know, being an anthropologist, I read Marshall Sahlins' Culture and Practical Reason, and of course he had read Jean Baudrillard on the political economy of the sign. And for me, in the 70s, this completely wrecked the notion of use value, because I realized, having read Sahlins, that use value was symbolically constituted. You can never say that something has a use value without actually making some kind of very personal judgment. I mean, you can't say that a use value is a certain physical metric. It has to do with what people want to buy. And that's why we have the neoclassical concept of utility. People want to buy certain kinds of things. They want to eat certain kinds of things. Like even Marx said that beef is not food to a Hindu, right? Pork is not food to a Muslim or a Jew. So use value is always a cultural issue, and that's why the economy is so interwoven with cultural issues. And we cannot imagine that there's such a thing as a neutral use value that can be established outside of cultural or economic context. So that I just wanted to explain why I had this point about use value.
Yeah, I would like just a brief comment, because I think that this idea of the difference is that not being an objective, sort of objective use value that you can establish for everyone. I think that this discussion has been had in some particular areas about the impacts of lifestyles. That's another way of seeing that. You're not talking about the value of GDP or the value of the consumption bundle, but you're talking about lifestyles, which is a more richer concept that relates also to the social reproduction in a similar way in which the notion of use value would relate. You know, but lifestyles allow for these differences, these cultural differences, and then you have to go into different regions of the world and see, well, in this particular area, you know, the food, it goes this way, and shelter goes this way, and so on. And that perhaps can be like in terms of modeling implementation, that you can have, if I understand correctly, Walther, like if you sort of establish these social objectives, sustainable social objectives, and these objectives could be contingent of lifestyles in different regions of the world that perhaps are the result of some democratic, you know, discussion and debate, and say, well, we want to go this way or we want to go that way. as opposed to establishing a very top-down kind of thing that this is how you should go about your daily life. So I
Yes.
said that lifestyle could be a very interesting concept for the debate.
Yeah, I would absolutely agree. So the only time I used exchange value in my presentation was at the very first slide. And I use it. So also Marx defined exchange value and use value as a description of capitalist values. So it's not necessarily the case that we have to have this differentiation in some sort of emancipatory economy or in democratic economic planning. So this is maybe something different. And I think the good thing about the newer debates, not only ours, but you heard Rue and all the others which are contributing since years to the newer debate on democratic economic planning. And the good thing about these decentral economic planning models is that you are free to choose. So there is no need to define use value of a product, or that you have to consume this or that. I think this is a very, let's say, the difference also to a top-down planning or central planning, as we have seen it in history, that we do not have to define that you have to consume this or that, but actually the model itself, the system itself, allows to adapt to regional or individual preferences.
Miriam?
Yeah, I just wanted to add something on this topic that Alf raised regarding implementation of an alternative system or something like that, because I don't know, the way I understood you, Walther, when you said, well, we could have, given all the things that the model can do, the SEA model, we could have print on the product some kind of real prices and so on. And actually, I think that that's the approach that companies are taking with LCA. That's what they use it for. They try to show you the footprints and so on. And I just don't think that that's the right way to go at all. I mean, what Alf is showing with the ecologically unequal exchange is the fact that this flow of resources and energy to certain parts of the world has spatial effects, which he showed first in the map. And those spatial effects are the accumulation of infrastructure, are the accumulation of capital. And I don't think it's as easy as solving, even as you said, Alf, that sometimes this, or often this ecologically unequal exchange rests on the fact that labor is cheaper elsewhere. But we've seen over years that the prices of labor may change. Sometimes it's cheaper in China, in Mexico, in India, and so on. And these structural inequalities, they remain. So beyond, I think, an issue of planning, I think it's an issue of politics. And I think that's a very important issue. I mean, the discussion we had this morning, I think it's very important to have these discussions because there is a lot we can plan. But I think that we have to realize that we're up against very difficult relations of power that we cannot get around. And so therefore, I think without the struggle part of that, it's essential. We're not going to get around anywhere. And I think it's awesome in the sense of like how huge it is to think of the social transformations that would have to happen to really change these technological relationships. And I think that that's what the aspect, that the spatial aspect and the kind of, that's why I was interested in raising this issue of materiality, whether we take it up with whatever kind of model, is the fact that we have this infrastructure that is material, that is over time, that is in space. And that's some like a very profound biophysical and social obstacle that we have to deal with if we're going to get around these changing this relationship. So it's just adding that I think we have to think on those dimensions of political struggle, social struggle before we really change anything. And despite that, I think it's great that we model that we think about it, that we realize what technology actually implies. But I think for changing things, it's got to imply something as big as that.
Okay, Walter, do you want to react? And I would suggest that then we maybe wrap up the session.
Yeah, maybe just a short reaction on that. So to come up with, let's say, these price labels on products, this was just, let's say, the first and dumbest idea I can give, because this would, I mean, this would be completely compatible on the one hand, to capitalist practice at a moment, to just put labels on something. However, it is also quite incompatible because companies do precisely not do print the environmental impacts, or they do not put environmental impacts or societal impacts of products on products themselves, as long as it's not serving for some sort of marketing trick. But this is the thing with LCA. You can use LCA for greenwashing, but you can also use LCA for discovering things which producers of products are not interested in at all. You know? So, and by the way, also the result of calculating such prices today, in today's economy and for today's products, would lead to exactly the insight that, for example, in Germany, we are using 3.3 times more resources, which are than we are actually we would be allowed to within planetary boundaries. And maybe one also addition to what the role of politics. So do not mix up cybernetic democratic economic planning as a societal system or some sort of transformation strategy itself. What I present here is a tool, is an economic tool which a society can make use of. But of course, this is embedded in not only a political system, which we do not define at this moment, and of course, it is embedded in an ongoing transformation, which is mainly the struggle of politics. So please consider it always only as an economic tool, which in any society has to be as big as it's necessary, but as small as needed.
Thank you. Then I would hand over to Miriam again for the final wrap up of today's workshop.
Yeah, the final wrap up was actually something that Sarah was going to do, and Sarah is ill today. In the end, we discussed not to have a final wrap up of all 3 sessions actually today. So I think we will end here with this workshop character of having had all 3 sessions, and we can close with that.
Okay. Yeah, thank you, everyone. As we said in the beginning, maybe we will also upload the recordings of the sessions on YouTube. I hope that my computer will not collapse now when I end the Zoom window, because then all the videos will be processed and saved. Fingers crossed that this works, but ideally, everything should work. Yeah.
Okay. Yeah. Well,
Yeah,
thank you
thank you
very much
very
for the
much.
invitation, and it was wonderful to see you and to hear you.
Yeah, thank you everyone for being here, for participating, for being here in the audience. And yeah, have a good evening, everyone.
Thank
And
you.
thanks a lot.
Thank
Thanks a
you.
lot.
Bye.
Thank you all.
Bye-bye.
Bye.
Bye-bye.
Dann beende ich.
Ja, sorry, dass ich das gar nicht mehr erwähnt hatte, aber Sarah war,
Ja, naja.
ich hätte gar nicht jetzt Closing Remarks. Ich habe gestern 2 Stunden geschlafen. Ich bin echt durch.
Ich bin auch so durch nach diesem Bewerbungsgesprächsmarathon und so weiter. Aber ja, hat ja alles ganz gut geklappt. Und dann sehen wir uns am
Wir sehen
Montag
uns am Montag, oder? Wir
um
beide.
18 Uhr, ne? Oder war es
Ja,
17 Uhr? 18 Uhr? 18 Uhr, ne?
ja.
Ja, okay. Und ja, ich habe am Montag tatsächlich noch einen Vorschlag. Ah ja, hatte ich erzählt, ne? Das ist jetzt wirklich gerade Primetime. Naja. Okay, ja, dann
Sag
erholen wir.
mal, noch eine Sache. Ich weiß nicht, wie lange Juliane noch krank ist, aber ich leite euch weiter. Ich habe diese furchtbare Mail bekommen von der Uni.
Mhm.
Die haben das nicht akzeptiert, so mit den Unterschriften. Und
Mhm.
eventuell muss man da nochmal Sachen ausdrucken.
Mhm.
Eventuell, da frage ich dich, weil du vor Ort bist. Wäre
Mhm.
das okay?
Mhm. Ja.
Okay. Eigentlich muss da Juliane unterschreiben am Ende. Ich streite mich da mit der Frau. Aber weißt du, was sie uns angemerkt hat? Sie hat es nicht unterschrieben, weil wir nicht mitteleuropäische Zeit, also
Mhm.
MEC geschrieben haben, sondern CET bei den
Wie ist das so
Verträgen. Ich
ätzend?
dachte mir,
Warum hat
ja,
die denn überhaupt so viel Power in diesem ganzen Prozess? Also,
weil sie ja die Prozesse kontrolliert. Also ohne sie, ohne dass sie die Sachen freigibt, können wir gar nichts machen. Deswegen heißt es immer gut machen mit, ja, aber ich war
Das
so
das
sauer,
wirkt
als
ja
ich das
wirklich,
las
als
heute
hätte die da
Morgen.
irgendwie ein persönliches, ich meine, wegen der Zeit, das ist doch
Sie ist eigentlich
völlig.
voll nett, aber sie ist eine Control-Freak. Sie hat
Ja.
mir geschrieben, ja, und wie kommt es, dass 15 Minuten später der nächste Talk und sie kriegen so viel Geld? Ich so, das ist Inhalt, das ist none of your business. Die sind da die ganze Zeit und diskutieren mit und schreiben da mit. Ist vollkommen okay, dass wir die Honorar vergeben. Na,
Hm.
also die Frau ist echt krank.
Frechheit.
Aber kurzum, wir müssen ein paar nochmal machen und dann gucke ich mal das. Ja.
Okay, gut,
Okay,
dann
danke,
schönes
Cornelius.
Wochenende erstmal. Und jetzt
Ja,
Daumen drücken, dass es mit der Videosicherung
ja,
klappt.
ja,
Das
ja,
wird jetzt
ja. Muss
wahrscheinlich ein
man
paar
diesen
Stunden.
Teil auch noch ausschneiden hier zwischen dir und mir und
Ah ja,
warum?
stimmt, ja, das macht Johannes dann. Ja, stimmt.
Okay,
Ah ja, das
hoffentlich.
wird ja eh noch zurechtgeschnitten. Okay,
Mach's gut. Tschüss. Tschüss.
tschüss.